In this very interesting series of sum and difference, here is question number 6. It's a communication problem, so you need to explain and answer your question. C6. You are given sum and difference of two vectors. Explain how can you determine vectors themselves graphically. So what we have done here is we have given you a grid, and here there are two vectors A and B. Let us say A, the vector A is equals to sum of two vectors. Let's say vector U plus vector V, right? And let's say B, vector B is difference of two vectors U minus V, right? So that is given to you. So that is vector A is sum of two vectors and vector B is difference of two vectors. Now you have to explain how can you find U and V. So that means you need to find what is vector U and what is vector V. So this is the question, right? So try to understand, analyze and answer the question, right? So have a good look. Now here is my suggestion. So we'll again go back to the properties of sum and difference, right? If we have two vectors, then what do the sum and difference represent? That is always the basic question, right? So let's review. If you have a vector, let us say U here, and vector V with some angle in between, then the sum of these two vectors can be found by making a parallelogram, right? So we can draw a line. So let us say we have a vector here which is U and the vector V is here, right? In that case, sum will be that I can draw vector V parallel to this, of course, of the same magnitude, right? And the line joining them will give me the sum of these two vectors. So that means this line is going to give me U plus V, correct? That is the sum. But if I join these two lines, then that gives me the difference, right? So let me just complete the parallelogram. Now what do you observe in this? What do you observe? Tell me. What you observe is, so this is U minus V, right? That they will always, these are the diagonals of a parallelogram, and diagonals of a parallelogram bisect, right? So that means this side is equal to this side, that's the midpoint, right? And this side is equal to this side. Now the question before us is that we are given the diagonals. Do you understand? We are given the diagonals and we need to find the vectors. Do you see that? So how can you find it? The easiest and the best way to do it is, as you know, earlier we were drawing the vectors. Now let's translate this vector. We know A is some vector. That means A represents this diagonal, tail to the other vertex. That is the sum, right? And that is my A. And B represents the difference, head to head. So what we can do is, we can translate this vector right there at the center. Since we know that the diagonals bisect in a parallelogram, so we will translate this vector right in the center. So this point, that center point, has to come here and we'll just draw it. So we have to go one unit right, one down from here to get the head. And to get the tail, one left, one up. One left, one up, and so we get the tail there. Do you see that? And we have vector B right there in the center. Translated, which bisects vector A, right? So that is my B, or B is actually the difference. So I have difference vector here. So this represents, now for me, U minus V, and this represents U plus V, correct? So what is U and what is V? I hope now you get the answer. Do you? It's not difficult at all. So U is, you can join these 2 points and get U, correct? So you get U, and that is your vector U. And vector V is, put them tail to tail and get both the vectors. So this is your vector V. Do you get my point? So this becomes vector U and that becomes vector V. So graphically we can find the answer, correct? So vector U with tail at 0, 0 and head at 3, 2, right? And I can write this as 3, 2. So that is my vector U. And my vector V is with tail at 0, 0 and head at 1, 4. So these are the position vectors which I have written here. So for convenience and for better understanding, I took A from the origin as a position vector, but A could have been anywhere, right? If A is suppose here, in that case also same process is followed and you get your initial vectors U and V, right? Isn't that wonderful? That is how you can find the vectors if you know their sum and difference when they are represented geometrically, right? So that is kind of a visual look at it so that now you understand it perfectly and forever. I hope you enjoy it. Thanks and all the best.